Let's try one more example, and that is if 8 tan theta minus 6 is 0 and theta lies between 90 and 360 degrees. First of all, we need to figure out an x, a y, and an r value. So we're going to start with 8 tan theta minus 6 is equal to 0 and rewrite it. So we're going to take 6 over to the other side and divide by 8. So we now have a fraction to work with. We now have to figure out the quadrant. We are going to start with tan theta is positive 6 over 8. So where is tan positive? According to my cast diagram, in quadrant 1 and quadrant 3. The next piece of information they give us is that theta lies between 90 and 360 degrees, which is quadrants 2, 3, and 4. The place where the information overlaps again is quadrant 3. Okay, now the definition for tan is y over x. Remember to put your angle from 0 to the hypotenuse. Alright, so the y value is 6 and the x value is 8, but there's a problem with those values. In that quadrant, x should be negative and y should be negative. But why don't I see them? It's because if I write down minus 6 over minus 8, I can cancel out those negatives. So I need to be careful when I do my drawing, when I do my sketch, I must take them back to their negative values and rewrite them as negative 6 and negative 8, even though I don't see those negatives in my original fraction. We need to calculate r. So we're going to do it using Pythagoras. So our x value is minus 8, our y value is minus 6. If I square them and add them, I end up with 100. And remember, r can only be positive, so I don't need to worry about positive and negative 10. It will only be positive 10. We now have an x value of minus 8, a y value of minus 6, and an r value of 10, which we are going to substitute in. So sine is y over r, so minus 6 over 10, which I will still need to square. Cos is x over r, so minus 8 over 10, which I still need to square. Minus 6 squared is 36, and 10 squared is 100. Minus 8 squared is 64, and 10 squared is 100. Subtract them, you end up with minus 28 over 100. And remember to simplify as far as you can without a calculator and no decimals. You end with a final answer of minus 7 over 25. You should now attempt the worksheet on Pythagoras problems. Let's add these two rules to our cast diagram. So 90 minus theta is an angle in the first quadrant, but I have to remember to change my trig function. And 90 plus theta is an angle in the second quadrant, but I need to change my trig function. And in the second quadrant, I just need to check whether my answer should be positive or negative. Let's look at a complete example. Okay, 180 plus theta is something that we've been doing for a few days now. It's an angle in quadrant 3. And in quadrant 3, cos is negative. Cos of 90 minus theta is in the first quadrant, but as soon as we see the 90, we need to remember to change the trig function. So it becomes sine theta. Cos of 180 degrees, that is on one of your axes. So remember to use your calculator. So cos of 180 degrees is minus 1. 180 degrees minus theta lies in the second quadrant, where tan is negative, but in this case our function is squared. So I'm going to have a negative times a negative, so I end up with a positive answer. So shortcut, if you see that a function is squared, don't even worry about the quadrant it comes from. It will always be positive. Theta minus 180 is in quadrant 3. Now remember, we start in quadrant 1, we move around to quadrant 3 because we're subtracting 180 degrees. And in the third quadrant, cos is negative. The last one we need to reduce is cos 90 minus theta. Now 90 minus theta lies in quadrant 1, but as soon as we see the 90 on the page, we change the trig function. How can we simplify further? Well, sine theta can cancel with sine theta, and minus cos theta can cancel with minus cos theta, which means our final answer is minus 1 over tan squared theta. Let's look at a longer example. Let's get our cast diagram and our table of special angles. First of all, sine 300 degrees. That lies in quadrant 4, and the rule in quadrant 4 is 360 degrees minus. So 360 minus what will give me 300 degrees? And it's 360 minus 60 degrees. The second trig function is exactly the same. Cos 240 degrees. 240 lies in the third quadrant. And in the third quadrant, the rule is 180 plus theta. So 180 plus what will give me 240, and it's 180 plus 60 degrees. Tan 225, well 225 also lies in the third quadrant, and there the rule is 180 plus. So 180 plus 45 degrees will give me 225. In our next step, we've just got to check which functions are positive and which are negative. So 360 minus lies in the fourth quadrant, and in the fourth quadrant sine is negative. The next function is the same. Cos 180 plus is the third quadrant, and in that quadrant cos is negative. And tan 180 plus, again third quadrant, but tan stays positive. We can now go to our table of special angles, our wagon wheel or our calculator, and minus sine 60 is minus root 3 over 2. Minus sine 60 again is minus root 3 over 2. Minus cos 60 is minus a half, and tan 45 degrees is 1. If we multiply, remember to show your baby steps. It is without the use of a calculator. So the first two, square root 3 times square root 3 is 3, and 2 times 2 is 4. Then minus a half times 1 is minus a half. 3/4 minus a half is a quarter. In trigonometry, we sometimes expected to write one angle in terms of a letter or another angle. In this question, if sine 15 degrees is equal to P, determine the following in terms of P. So what they're asking me to do is any angle that I'm working with, I'm going to try and write it or reduce it to 15 degrees. In the first example, we get sine 165 degrees. Now, I just want to have a look at the cast diagram to see where that fits in. Now, 165 degrees is in the second quadrant, and the rule in the second quadrant is 180 degrees minus theta. And it just so happens that 180 degrees minus 15 degrees gives me 165 degrees. Now in the second quadrant, sine is positive, so I don't need to write the 180 minus anymore. I can reduce it to sine 15 degrees, which is positive, and sine 15 degrees is P. So sine 165 degrees I can rewrite as just P. The second example, we get sine 345 degrees. Now 345 degrees lies in the fourth quadrant. And in the fourth quadrant, the rule is 360 minus theta. And it just so happens that 360 minus 15 degrees gives me 345 degrees. Now in the fourth quadrant, sine is negative, so I can reduce that angle to minus sine 15 degrees. Sine 15 is P, so I can simplify that to minus P. In example C, we want to know sine of minus 15 degrees. Now remember the lesson from negative angles. Minus 15 degrees will be measured down into the fourth quadrant where sine is negative. So negative sine 15 degrees can be rewritten as negative p. Sine 375 degrees. Now that angle is greater than 360. So that's all the way back in the first quadrant, because I can rewrite 375 degrees as 360 degrees plus 15. Now in the first quadrant, all my trig functions give me positive answers, so I can reduce that angle to sine 15 degrees, which is just p. Cos 75 degrees. Now my function has changed, but I need to remember 75 degrees lies in the first quadrant, and I have another rule in the first quadrant, and that is this 90 degrees minus theta. So I can rewrite 75 degrees as 90 minus 15 degrees. But we need to remember, if we're using a 90 minus rule, the function must change. So cos changes to sine 15 degrees, which is p. The last two questions we're going to have a look at is if I'm given a different trig function but the same angle. So cos 15, and we're going to look at tan 15 just now. And because I can't use my normal reduction methods because the function is different, I need to make a slightly different plan. Now we have got an identity that we can use. Remember that sine squared theta plus cos squared theta is 1. Theta can be any angle. In other words, sine squared 15 degrees plus cos squared 15 degrees is also 1. And if I rearrange that, I want to try and get cos 15 on its own. So I can take sine squared 15 to the other side. And if sine 15 is p, I can replace sine squared 15 with p squared. So cos squared 15 degrees is 1 minus p squared. And if I want cos 15 on its own, I can square root both sides. Now I'm not allowed to square root each of those individually. I have to keep it as the square root of both. So that is your final answer. There's another method that you can use if you prefer. If we go back to the fact that sine 15 is equal to p, I can rewrite that slightly differently. I can rewrite it that sine 15 degrees is p over 1. I'm not changing anything, but if I look at it in that format, I've got a fraction, and I know the definition for sine is y over r, which means I have a y value of p and an r value of 1, and I can create a little Pythagoras question with it. So 15 degrees is an angle in the first quadrant. I know that my p value goes in place of y, and my r value is 1, and we can then use Pythagoras to calculate the x value. Now why do we need to calculate the x value? Because the definition of cos is x over r. So x squared plus p squared is 1 squared, which means if I take p squared to the other side, x squared will be 1 minus p squared. And if I square root both sides, I get that x is equal to the square root of 1 minus p squared. The definition then for cos 15 is x over r. My x value is my square root, and my r value is 1, which can be simplified to the square root of 1 minus p squared. Both methods give me exactly the same answer. You can choose which method you would like to use. The other one I want to discuss is tan 15 degrees. If you prefer to work with your identities, remember that tan 15 I can rewrite as sine 15 over cos 15. Sine 15 we were given as p, and cos 15 is the square root of 1 minus p squared. So tan 15 I can rewrite as p over the square root of 1 minus p squared. Alternatively, if you prefer to work with the sketch, the definition for tan 15 degrees is y over x. We've got our y value from the sketch and the x value we calculated. So rewrite it as p over the square root of 1 minus p squared. Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.